Hello, everyone. I'm Sian Proctor, the Science Communication Outreach Officer on the JOIDES Resolution Expedition 383, and I'm here with Sedimentologist Jesse Farmer. Jesse, what interesting things have you learned about these cores?
Welcome back to the Core Deck, Sian. It's great to have you back here as always. So there's so much information in this, and I should point out, we've had a chance to look at this on deck for really only a couple hours, right? And so the learning process is just beginning. There's so much more information, even looking at kind of atom by atom ratios of materials in these sediments, that's going to tell us really quantitative information about climate in the past. Right now is the sort of fun part. We're sort of storytelling in our minds about, based on what we see here, what can we infer about how climate might be in the past, and really setting up hypotheses that we'll test with more data once we get back to land. But some of the really cool things here that really stick out to me, you've got the really dramatic color changes, and we talked about how this is really a function dominantly of the organisms living in the surface ocean and sinking down to the bottom, and how that's changing over time as climate's changing. But there's a lot more going on here too, and one thing I want to pull your attention to is right here we've got this little gap in the core, and actually if you could press on this, it's hard.
Oh yeah. That's cool.
That's a rock. And
wow.
We're thousands of miles away from land. We're about as far away from land as anyone can get. How do you get a rock into the middle of the ocean?
That's a good question.
And just to show you, confirm this as a rock, we have a ton of technology on the JR here. And one of them is we take X-ray sections of all these cores. Just like if you break a finger, you break an arm, you go get an X-ray, we're doing the same thing with mud reaching back over hundreds of thousands of years. And where that rock is that I pointed out, so right here, we can see it on the X-rays, this very dark patch, and that's what we call a dropstone. So this piece of rock is about 2 centimeters long, about 2 centimeters or so in diameter. And where that came from, that was most likely part of Antarctica, the Antarctic continent, that was pulled off by an iceberg. That iceberg drifted north from Antarctica, covering over 1,000 miles, eventually melted over the location where we just happened to take this core, and dropped its in this case, its rock down to the bottom of the ocean.
And then it got buried in the sediment.
Got buried in the sediment, then a couple 100,000 years we come back and we retrieve it back from the bottom of the ocean.
Wow, that's really fantastic and crazy to think about. So what you see when you split these cores open isn't necessarily everything, because hidden inside, underneath this top layer, can be things like dropstones.
Absolutely, and you can, just looking at this image, there's a lot of other information here that you can't, this looks kind of plain. It looks like kind of basically one color with just the exception of that dropstone. But you can see all these evidences of different burrows, different organisms that are churning up the sediment in the past. And there's a lot, all of geology is really looking at every single possible layer of the material we get and trying to learn as much as we can about every single feature using any sort of technology that we can get our hands on.
Well, that's really great. Thank you for sharing that with us, Jesse.
No problem, anytime.